Hello, this is Nicholas, and I had kind of a cool question that I found that I wanted to make a video on, and the question itself is rather simple. How many solutions to the equation a plus bi raised to the 2002 equals a minus bi? How many solutions are there to that equation? Okay, so you may know from a theorem by the name of De Moivre's, probably I'm spelling it wrong, that when you have a complex number z, which we'll let to be a plus bi, when you convert z into polar form, right, where you've got, right, normally we're considering points based on their distance from the origin, their distance x and y in Cartesian, but in polar we name points based on their radius r and their angle that they make theta. And when you convert complex numbers into polar forms in the Argand field, and the Argand field is just another name for the complex plane, then visually they have a nice representation. So let's say, so I'm gonna let z equal to a plus bi. And this is Cartesian. So in rectangular, Cartesian is another name for rectangular. In polar coordinates, z is equal to r e to the I theta, where e to the I theta is equal to cosine theta plus I sine theta. And this is a very famous equation from Euler, and it turns out that if you let theta be pi, you get e to the I pi is equal to -1, which is probably one of the most beautiful equations in math. Anyway, so z is equal to re to the I theta. Now when you square, let's say we're squaring re to the I theta. Okay, so let's say maybe this right here, this is r, let's say this is theta. Now when we square that, and let's say r is equal to 2 in this case, then what we're going to do, we're going to have this length now is r squared, which is 4, and now this angle is 2 theta, right, because 2e to the I theta squared is 4e to the 2 theta I, right? And so that's what's happening. Now if you were to square that again, you would again double your previous angle, and you would you would square the length of the other side, so you'd have something going way out, like that, and that would be 16, and then this angle here would be 4 theta. Now hopefully you can see that if we let r be, and also r is going to be positive, right, because it's a radius, it's a positive quantity. If r is greater than 1, right, then as you raise this number to a very high power, like 2002, you're not going to get any solutions to this equation, right? Your radius is just going to get very huge very quickly, and it's just going to go off the charts. So, now also realize, I'm going to draw that for no solutions. If r is equal to 0, then you're just going to have this point right here, raising 0 to the 2002, which is still going to be 0, which is 0 is the conjugate of 0. So that is a solution, right? Because 0 plus 0i is equal to 0 minus 0i. So that's a solution right there. Now let's talk about if r is equal to 1. So in other words, we're only considering e to the I theta, or you could put 1 here, 1 e to the I theta. We're letting r be 1. Okay. Now, so if we were to imagine plotting this, right? So let's say maybe this is theta. And maybe this distance is a and this distance is b, right? And maybe this point here is a plus bi if we're in the Argand field. So a minus bi, so we go a, but now we're going down b. So I'll put a negative. And we'll say this point here would be a minus bi. All right. So hopefully you can, and I'm going to make this positive theta, right? Let's say this is some positive angle theta here. Then this angle here, right, is just negative theta, right? They're opposite of one another. So you get that nice kind of reflection. Okay. So since r is 1, right, all you're going to be changing is your angle. So you just want to, you know you're going to get solutions then. So basically you're going to have e to the I theta to the 2002 is equal to e to the negative theta I. And again, right, we have e to the I theta and e to the negative theta, right, because there exists this symmetry here. There's this symmetry, which is the whole point of why I drew this here. Now, what I'm going to do is I'm going to multiply both sides of this equation by e to the I theta, and you'll see why. Hopefully you already do. This is going to give me e to the 2003 theta I is equal to 1. Right, because here you'd add these exponents and you'd have e to the negative I theta plus I theta, which is 0, and then e to the 0 is 1. Okay. Now, right here, we said z was e to the I theta, so